All right, next we're just going to go ahead and knock out nitrogen, phosphorus, and the sulfur cycle. So first we have the nitrogen cycle in a terrestrial ecosystem with major harmful human impacts. So basically we know nitrogen is the most abundant gas in the atmosphere. We have 78% of our atmosphere is made up of nitrogen. And the first thing that has to happen is that you have to go through nitrogen fixation, and this can happen either through lightning, which is a natural process, or it also happens through nitrogen fixing bacteria. And what that does is it makes some ammonia and ammonium, and then in order for the plants to uptake this nitrogen as nitrates, it has to go through nitrification, also by bacteria. And this happens through special rhizobiomes that have a symbiotic relationship on the roots of the legume of a plant. And then your plant will use this. Your plant will end up using the nitrates, and then your animals will eat the plants, and they'll both die and decompose. And when that happens, you get more ammonia back into the atmosphere, which needs to be, back into the ground, needs to be broken down. And that happens through the process of ammonification. But before that happens, actually, when I was saying plants uptake the nitrates, I don't want to leave out the fact that they go through assimilation. And assimilation is pretty much the process where the nitrogen is used basically to produce amino acids, proteins, nucleic acids, and vitamins, all those things that are pretty much essential for building blocks of life. So anyway, so then they eat it, they die, they decompose. You have the ammonia in the soil. So it needs to go through ammonification to make it basically simpler nitrogen compounds like ammonia and ammonium after all these organisms are dying. And then lastly, in order for the nitrogen to make it back into the atmosphere, you have denitrification. And again, this also happens using bacteria. Bacteria does this for us. So anyway, human impacts from the nitrogen cycle are basically that since we are adding all this nitric oxide into the atmosphere, because when we burn these fuels, such as jet engine fuel, it turns into nitric oxide into the atmosphere. And then if it's in the atmosphere like that, it can be turned into nitrogen dioxide gas or nitric acid vapor, and then that can return back to the earth as acid rain or acid deposition. And then we add nitrous oxide to the atmosphere when we have our anaerobic bacteria that break down livestock waste, and commercial inorganic fertilizers are applied to the soil, and that is a greenhouse gas, and it warms the atmosphere. Then we also release this nitrogen in soils that's usually stored in the soil and plants as gaseous compounds into the atmosphere because we destroy forests and grasslands and wetlands. The sulfur cycle, phosphorus cycle. This is basically the only gas, the only cycle we'll talk about that is actually not found in the atmosphere already. This is actually stored in the rock, but what happens with the phosphorus is that most soil doesn't have a lot of phosphorus in it because it has basically run off into the water, and then it doesn't absorb very well in the water, so a lot of times it will just sink to the bottom, and so it takes millions of years for whenever uplift happens of the land that was in the ocean. That's how you get it exposed back up again. And so they find the pockets of the phosphates, and they end up adding that to fertilizer. Remember when you see fertilizer bags, they'll say 10-10-10 or 30-10-30, and that is the quantity, the ratio of nitrogen to phosphorus to potassium or potash. So you have, that's the limiting factor in plants, so therefore it is added to the plants. And since it isn't usually found often in the water, when it is run off from when it's put on plants as fertilizer and then it goes into the ocean, into the river system, then it causes the eutrophication, and that's how we get a lot of algal blooms, because they're not used to having that much phosphate, and it can be very problematic. Okay, and now we have the sulfur cycle. And sulfur is usually found underground. It's found either in organisms, ocean sediments, soils, rocks, and fossil fuels. And the sulfur dioxide in the atmosphere, it usually ends up mixing with the H2O molecules already found in the atmosphere, and then that's when it kind of comes down as sulfuric acid, H2SO4, which is the major component of acid deposition. But also you'll find there's some natural occurring ways for sulfur to circulate through the biosphere, usually through the salts that are stored underground as rocks and minerals. It's usually a sulfate. The SO4 2- are actually salts that are buried deep under the ocean sediments. So we actually mine that and get it back out into the atmosphere. But it also comes from the volcanoes. And so when you have volcanoes, it emits the hydrogen sulfide, H2S, which is a colorless, poisonous gas, and it kind of smells like a rotten egg. And then your swamps, when you're decomposing the anaerobic decomposers, decompose in swamps and bogs and tidal flats, you'll smell that sulfur dioxide, is SO2, and that's also colorless, suffocating gas, which comes from volcanoes as well. So there's definitely some ways that they enter the atmosphere. The sulfate salts I was telling you about enter also naturally because of sea spray, dust storms, forest fires, etc., etc. So the major number one way, though, that we get it back into the atmosphere is when we burn dirty coal. So when we burn dirty coal, because that sulfur has been stored in the rock in fossil fuels, it's found often with the coal. Remember, your anthracite coal is the purest form, so you'll have less sulfur at least entering the atmosphere and less sulfur particulate entering the atmosphere if you use a cleaner coal to burn.